The telescope is, without a doubt, the essential research tool in astronomy. It allows for the collection and analysis of radiation from celestial objects, even those in the remote reaches of the universe. The Hubble telescope can see the farthest galaxies. The Webb telescope will see the farthest stars. Heidi Ham. Following Hubble, the James Webb Space Telescope, JWST, is the most important space research observatory. On December 25, 2021, it went live. The telescope was launched from Europe's spaceport in French Guiana aboard an Ariane 5 rocket. The telescope is named after NASA Administrator James E. Webb, who worked on the Mercury, Gemini, and Apollo programs from 1961 to 1968. JWST is an infrared space telescope. James Webb is the most powerful space telescope ever launched. Its higher infrared resolution and sensitivity will enable it to see things that the Hubble Space Telescope cannot. This $10 billion telescope will be used to investigate how stars and planetary systems emerge, as well as the evolution of galaxies, exoplanets, solar system objects, and the early cosmos. Webb was developed in collaboration with NASA, the European Space Agency, and the Canadian Space Agency. The telescope was built by NASA's Goddard Space Flight Center, GSFC, in Maryland and is operated by the Space Telescope Science Institute in Baltimore. The mass of the James Webb Space Telescope is nearly half that of the Hubble Space Telescope. The JWST's mirror is made up of 18 independent hexagonal mirrors with a diameter of 6.5 meters, 21 feet. A gold coating provides infrared reflectivity and endurance to the mirror. JWST is primarily intended for near-infrared astronomy, although it can also view orange and red visible light, as well as the mid-infrared area, depending on the instrument. It can detect objects up to 100 times fainter than Hubble, as well as objects from considerably earlier in the universe's history, dating back to redshift Z20, about 180 million years cosmic time after the Big Bang. Hubble can only see back to around Z11.1 billion years. Galaxy GNZ11, 400 million years cosmic time. The JWST is in a halo orbit, orbiting at the Sun-Earth L2 Lagrange point, about 1,500,000 kilometers, 930,000 miles, beyond Earth's orbit around the Sun. As it revolves, its actual position varies between 250,000 kilometers, 160,000 miles, and 832,000 kilometers, 517,000 miles, keeping it clear of the shadows of both the Earth and the Moon, whereas Hubble circles 550 kilometers, 340 miles, above Earth's surface. It's virtually finished preparing for science missions that will forever impact astronomy, astrophysics, and many other sciences. Webb sent back some test pictures. The photographs were released after the lengthy process of fully focusing the telescope's mirror segments was completed. Engineers claim that JWST's optical performance is better than the most optimistic estimates, and astronomers are overjoyed. Webb's image of an 18-star mosaic. The JWST revealed an astounding sprinkling of 18 stars dispersed across a black background in February 2022. The image, however, is a ruse. All of the bright stars overhead are one and located in the constellation Ursa Major, also known as HD 84406. It merely looks to be numerous because Webb's mirror parts had not yet been fully aligned. More than 20 years ago, the JWST team set out to build the most powerful telescope that anyone has ever put in space, and they came up with an optical design to meet the science goals, said Thomas Serbuchin, an associate administrator for NASA's Science Mission Directorate. Alignment image of 2-mass J17554042 plus 655127.7. The James Webb Space Telescope was brought into focus on March 11, 2022 by directing the telescope toward a single star, 2-mass J17554042 plus 655127.7, plus a few others nearby. This was known as the alignment image. By combining the 18 distinct images, the precision of the resolution was raised to 50 nanometers. And this is only a fraction of the wavelengths Webb will capture fully operational. Image of the Large Magellanic Cloud. Webb's most recent image was released on May 9. A stunning view of the Large Magellanic Cloud, a satellite galaxy near the Milky Way, the mid-infrared instrument, MIRI. It focused on a star field within the satellite galaxy to test the imaging capability of the James Webb Space Telescope. These breathtaking panoramas show how powerful JWST will be and how far infrared astronomy is about to advance. And that's only the beginning. Webb will also look at moving objects in our solar system, offering scientists a cutting-edge tracking and imaging system to let them focus on things closer to Earth. The James Webb Telescope is a Hubble replacement that NASA expects to be operational by the end of June 2022. On July 12, 2022, the Webb Space Telescope will unveil its first full-color photos and spectroscopic data.